Hello everyone, myself Dr. Shiraz. I am going to explain the working of smart converter that we have developed in our lab. In most of the converter that we use in our home, I am just particularly talking about the inverter. We have display devices which shows only the values of the current and voltage. They does not show, they don't show the value of the waveforms of the current and voltage. However, according to me, the waveform of the converter, it can be the indicator of the health of the converter. So it is much better we should have the waveforms also. But to have a waveform, we should have an oscilloscope or display devices which are too costly and which is difficult to include in the converters. Just to resolve this problem, what we have done, we have developed a smart converter in our lab, and I am going to explain the working of this smart converter. In front of you, there is a smart converter. Actually, this converter includes two converters. One is the AC to DC converter, and another one the DC-DC converter. The first stage, we have a AC to DC converter, which is a bridge rectifier, which converts AC into DC, and this DC is being supplied to the DC boost converter. Now see here, on the front stage, this is a AC to DC converter who is converting AC into DC. Now I'm making it on. Now my AC to DC converter has started, and now DC is being supplied to this boost converter. Now this is my DC boost converter. Now after that I am making on DC converter. Now my DC converter start working, and now this DC converter working in closed loop operation. For this purpose, I am using voltage control loop and current control loop. So for just to control this converter, what I am doing, first of all, I am sensing the voltage and output voltage and current of this DC boost converter, and this voltage and current are being sensed by the voltage sensor and current sensor, which are given on this converter, DC boost converter. Now this information being supplied to the sensing board. Now on this upper side of this converter is a sensing board which I am using here. Now the necessary attenuation of these signals is carried out by this sensing board, and this sensing board convert this signal which is suitable to the DSP 2837990. Now the operation of this DC boost converter is being controlled by DSP 38279D. Now after doing the necessary processing of these signals and taking the control actions, now these are firing pulses are supplied to the gate driver, and gate driver supplying these switching pulses to the DC boost converter. After that, I am going to capture the waveforms which are being which is the input waveform and output waveform of DC boost converter. For this purpose, what I am doing, whatever current and voltage I am getting from the DC boost converter, I am supplying this voltage and current information to the Arduino Mega. Now I am using UART communication between Arduino Mega and this connection screen, which is a touch screen, and due to this whatever information is being supplied on the on the receiver pin of this Arduino, the same data is being transmitted to the receiver pin of the connection. Okay, now I will show you how I am capturing the waveform. Now I'm just this is my in front of this is the front display. So first of all, I will press proceed. Okay, I press it here. Now I have four options. I can observe the input voltage V1, output voltage of DC boost converter. I can observe the output current of input current of boost converter. I can observe the output current of boost converter. So first of all, I will observe input voltage of DC boost converter. Now this is my output. This is the input voltage of DC boost converter. Now see here, since I have started, now it has started capturing the waveform. Now initially its value was 0 when it was not on. As soon as it becomes on, it starts capturing some non-zero value of the voltage. After that, I am going to the next stage. This is my output voltage of DC boost converter. Similarly, on the next, this is the input of DC boost converter, which is the inductor current. And what is happening here, it is being clearly visible from here. Whatever spikes are coming in the current. Okay. Now this is my output current of DC boost converter. This is all about the about this smart converter, and I am very much thankful to NPRP project who has funded this converter, and I am also acknowledge the help provided by Professor Atif to develop this type of converter. I am also thankful to Engineer Tala Janu who has actively helped to develop this project. Thank you very much for listening patiently. Thank you very much once again.